Well, hey guys, welcome back to the channel and welcome back to something quite different for the channel, but this is one of those products that I saw earlier last year and I've always questioned whether they actually work. So I've reached out to SOLDERSTICK and they've sent me this box of connectors and we are going to test lots of different scenarios and factors and different data with these connectors to see if they're appropriate for the RC hobby. So stay tuned and we'll do a hardcore test on these solder connectors. All right, guys, so we've got this box of many different connectors here from SOLDERSTICK. So these connectors, I saw them a while ago, always question them whether they actually work or not. So that's what we're going to do today is we're going to give this a very thorough testing. All of our tests are going to be related to the RC world. So we're not going to do any wire testing on wire that we wouldn't normally use in our RC aircraft. So it's going to be a pretty awesome, thorough test on these connectors. Question number one, do these connectors actually even work? We're going to test that. Is there a significant voltage drop between this style of connector and a standard solder joint? We're going to test that as well. Do these connectors actually hold the wires together enough so they can't be pulled apart? We're going to test that. Is there a significant difference in resistance through the wire when using one of these connectors versus a standard solder joint? We're going to test that as well. So I've got a discount code for you guys for orders from this company. So before I give you that, let's do our testing and make sure that Trusty actually approves these connectors first. All right, test number one, we're going to make sure that these wires and connectors, solder stick connectors, actually do what they're supposed to do and connect these wires together. So we're going to be using 3 different wires for this test. Number one, the thickest gauge one that we're going to be using is a 16 gauge silicone wrapped wire. Now this is wire that we would generally use for running power lines and stuff like that on an aircraft. Next wire down we're going to be using is another silicone wrapped wire, and this is wire from a Unilite lighting setup. So this is another wire size that I commonly use. So that's the second one we're going to test. And then the third one we are going to use Powerbox Maxi wire. Now Maxi wire, the white wire is smaller diameter, so we're not going to use the white wire, but we'll test to make sure that these connectors can actually join servo wire, which is fairly small gauge, together. So the diagram on the container here shows you the different connectors and the gauges that they're used for. So something like our thick silicone wire is a 16 gauge wire, so we should be using the blue connector for this particular wire, which is that one right there. Our Unilite wire, we're probably going to be using the red connectors, which is 22 to 18 gauge, which is those guys right there. And the Powerbox servo wire, I pretty much think we're going to be using the white one. So we'll get an opportunity to test the white, the red, and the blue connectors. The yellow ones are the obviously larger connectors for 12 to 10 gauge wire. So we'll get the test all set up and get everything ready to go. When you're using these connectors, you're not using a soldering iron, you're using a heat gun. All right, so this would be my normal process for soldering 2 wires together, but we would be using solder and then putting a piece of heat shrink tubing over top of it. Now, the benefits of using these low temperature solder connectors is you've got a seal, which is a waterproof seal, and your shrink tubing and solder all built in one. Now, I have never used one of these connectors before. This is the first time, have not done any tests on it or anything. So we've got this all set up, and let's see how it works. We're using a electronic heat gun. We're going to set the temperature on high, and we'll see how this thing works. Let's go. So the solder's flowing and melting, I can see that. Oh yeah, I can see it melting into the wire. So we'll shrink the shrink wrap here. Wow. Let's take a look at it and see. Huh. So initial impression, very cool. Like I said, I've never used one of these connectors before. That was the very first time, and really slick looking. I'll try and get some close-ups here with my face as a background, maybe my hand as a background. So if you look closely, on the edge, right where the black and the red is, you can see that the solder actually completely melted into the wire, which is really impressive. Wow. So let's do those other wires, the smaller ones with the other connectors, and see if it's just as easy. So this Unilite wire is actually a very low strand wire. So there's maybe, I'm just guessing here, maybe like 10 strands per wire. So this is something that we wouldn't generally use except for like power wire on an RC aircraft. So this will actually be a good test. That first wire was a very high strand wire, and it'll be neat to see how different it reacts with this low strand wire. Now the reason I'm clamping it like this is visually to make it easier for you guys to see. I don't know if this is 100% necessary, but this is going to give us the most amount of working space around this. So let's test the red connector on the next wire size down. Wow, the solder flowed perfectly. That was really nice. All right, so that was perfect. Really, really impressive. I could see the solder just go and completely flow out. That's the technical noise that it made. And all the way around that connector, no problem. And actually right now, with the residual heat, that's still not cured. So you could actually pull that apart right now. So we'll have to let that set for a little bit. Okay, so we'll get our final wire that we're going to test just to see if these things actually work, our servo wire, and we're going to use probably the white connector on the servo wire, even though the actual wire is probably the same gauge as the red and black Unilite wire. We'll try the white ones and we'll see how that goes. Maybe we'll try the red ones, but we'll do the white ones initially here. All right, guys, well, I am thoroughly impressed already, and my skepticism has been quelled. Let's try the smallest white connector on the servo line. Yeah, you can see the solder flowing. Now this one has quite a bit less solder, it looks like, in it. So I can still see some of the wire showing. But you can see, actually the solder, you can see it where it went into the wire. So it's actually really good, quite impressed. I think Like I said, we could probably use the red connector on servo wires as well too, but we'll just use these two and see what happens. So yeah, very impressed with these things already. And it's completely encapsulated the wire. There's a little bit of the strands showing right in the center part, but really quick, really impressive so far. Okay, so while we've got these 3 wires hooked up already, one of the concerns that I had was a pull test with these things. So I want to make sure that these things aren't going to come apart. Now, from what I've seen with the amount of solder that is in there, I don't think it's going to be an issue, but we need to run the test anyways and do a pull test on this stuff. So we'll get that hooked up. So for our pull test, what I've done here is I've made a figure-8 knot on each end of the wire. We're going to hook this up to our digital scale, which is right here, and we are going to add some pulling force to the wire to make sure that the connectors don't come apart. Now, the thicker gauge wire, the 16 gauge wire, I suspect it can hold a lot of weight. The thinner gauge wires, I see the wire probably breaking or the connector coming apart, so we'll add some decent force to this. I'm thinking maybe about 40 to 50 pounds for the bigger wire, maybe 20 pounds for the thinner wire. But we'll record it and we'll see what happens and go from there. First off, we've got our thicker 16 gauge wire. We're holding it about 4 inches away from the connector, and we will add some force here and see what happens. So I'm not sure the number, but our joint came apart at whatever that weight was. Now we'll do our medium gauge wire with the red connector and adding force now. And with this wire, our wire itself ended up breaking, not the connector. Now we'll do our thinnest wire, our Powerbox Maxi servo wire, and adding force now. So this one is a little bit hard to see, but it actually didn't come apart at the solder joint. The wire broke on the other side of the solder joint at whatever that weight was. So I know some people would want to see a control test where you're doing a pull test on a standard wire, like a soldered wire connector. I'm not going to do that because I'm not overly concerned with the pull results of this. It's not a structural way to join wire together. All we're doing, and the whole purpose of that was just making sure that it actually withstands some force, and you can't just yank it apart with 1 to 2 pounds of force. For our next test, we're going to measure resistance across a bunch of different types of connections. So what we've got set up here is we've got 33 feet of power wire. This is the 16 gauge stuff, same stuff that we did the initial testing with. So we've got 33 feet of black, 33 feet of red. We've got one end of our voltmeter hooked up to the red side, another end of our voltmeter hooked up to the black side, and we've got the wires themselves joined in the middle. So right now the wires are just physically squished together and joined. We're going to test the resistance between this setup, a standard solder connection, and one of the solder stick connections. We're going to use 2 different voltmeters just so you can see the difference in readings between the two. So with our, we'll just call it our micro voltmeter, we're going to go to resistance, and we can see there the resistance is 0.4 right now. And what we'll do is we're going to switch the voltmeters out to the other voltmeter, the large one. And the reason I'm not just using the large one is because the only setting I have available on it is also a continuity setting, so you'll hear it beep as soon as I do this, but it does give us a different reading. Okay, so we've got the wire connected there in the same path as before, and we've got a reading of 0.7 is our resistance. So now we've got our control set up. what we're going to do is we're going to do a standard solder joint on this wire and see if that resistance increases, stays the same, or decreases. And then once that test is done, we'll use one of the solder stick low temperature connectors and we'll see how that changes compared to the control test. All right, so our joint has been soldered. The solder's been allowed to cool down, so it's I can feel just a little bit of warmth there, but it's really not much of anything. So we've got our mini tester hooked up here again too, same fashion as before. Let's see what the resistance is. So we are now sitting at 0.4, 0.3, so no real change with the solder joint. Let's hook the regular voltage tester up, or the larger one, and see if there's any difference there. All right, and we've got 0.8, 0.7 again, so again, no real noticeable difference in the amount of resistance across the standard solder joint. So what we'll do now is we'll use one of the solder stick connectors on that joint and check and see if there's any difference. All right, so we've got our solder stick connector on there as we did previously, and we've got everything hooked up like we did previously. Go to resistance, and 0.3, no noticeable difference in resistance. So again, we'll hook up the large voltmeter and see if that gives us a different reading. And we have 0.8, 0.7 again, so again, no difference in resistance with the solder stick joint. All right, guys, final test that we're going to do is voltage drop to see if there's any difference. So that's part of the reason why I've got such a long section of wire is number one, to see if we can get any resistance increase, and number two, to see if we get any voltage drop. So what I'm going to do here is I'm going to get a connector soldered to one side. That allows us to plug it in to a constant power source, and then we can measure the voltage at the end of those wire runs. So we'll have 33 feet on red and black. We can measure the voltage and see if we have any power drop. Now when we do our connectors, we're going to put them close to the power source, not at the very end. I'm excited to see the results of this. So one interesting point here, guys, I thought I would show you on camera as well, is I just cut this connector open, and this one I made sure I heated up a little bit more. You can actually see the solder all the way through that joint. So this is the connector that we just tested, and so I think adding a little bit more heat is a good idea. All right, so for our voltage test here, we've got our wires hooked up to our power supply. And we've got our 33 feet of each wire, and our voltage meter is plugged in to each end. So what's going to happen here is we've got our voltmeter or our power supply set to 8.0 volts, 5 amps, and that's going to output it through the wire, and we're going to measure it at the voltmeter. So let's start our power supply. So it's starting. We're at 1.6 watts. And we are measured at 7.97 volts. So that means that through the control, so no solder joints in here except at our connector, we are losing 0.02 to 0.03 volts throughout this entire length of wire, which is way better than I was actually expecting. So now what we'll do is we will cut this wire about 1 foot away from our connector, and we will do a standard solder connection and see if that changes anything in the system. And actually here you can see we're up to 8 volts, so there's basically zero loss, really zero loss among this whole setup. All right, so test number 2, we've got our standard solder joints here. Everything's been hooked up just like it was previously. We'll start our power supply. Same settings on the power supply. And we'll see if there's any voltage drop. No difference really, so 7.98. And we're back up. So what we'll do now is we'll do our solder stick connectors and see if there's any change. All right, so we've got our solder stick connectors on there, and I gotta say, the more I use these things, I am actually very impressed. So everything's set up the same way. We've got all of our same settings. So we'll start our power supply, and we are same thing, 7.9897. So essentially 0 voltage drop, and we're back up to 8 there. So awesome. So just for my own curiosity, I'm going to redo the pull test with the big wire. And what I'm going to do differently this time is I'm going to add more heat to that connector, and I think it's going to work out better. So I just want to confirm that with the pull test. So I'll get that set up and we'll do that one more time. All right, guys, one more time on this pull test. As I mentioned, we added a lot more heat to the connector, and let's see what happens here. So, whew, we're over 50 pounds, and nothing happened to the connector at all. So more heat is definitely better. So that was actually enough that you could see an indent on my hand there. I was pulling pretty hard, well, obviously 50-ish pounds. So anyways, that connector worked perfect this time, so definitely add a lot more heat. The very first time I was worried that I would melt the heat shrink, but you can just keep going and going and going with the heat gun and nothing happens. So let's cut this guy open and take a look at it as well. Okay, so our connector here, we'll just cut it open straight in half. So as I showed you before, you can see the solder is a lot more impregnated into the wire. It's basically fully impregnated in there, and that worked out beautiful. Well, guys, here's the results from the solder stick test. Trusty, bent screwdriver, and me would definitely approve of this product. It's not very often that you come across a product like this that does what it's actually supposed to do, and it's a huge time saver. So I can definitely confidently say that I will be using this product from now on in the builds of all the aircraft that I do. This is a huge time saver. I think it's a better quality solder joint as well too. Just a way cleaner solder joint. It's better protected, and I'm very, very impressed with this product. All right, guys, there are links down below. There's a link in the description, link in the first comment for SolderStick. You guys can get a discount when you use that link and use my discount code that I've asked them for you guys. So, just got my phone up here. So the discount code is Jonathan20. You'll get 20% off your order. So again, links down below, discount code down below. If you build airplanes, guys, whether they're turbine jets or whatever you're using, definitely check these things out. Again, I am thoroughly impressed with this product. Thumbs up for sure. Trusty approves. I approve. Thanks, guys, for watching this video. Check out SolderStick's website, and we'll see ya in the next video.